Welcome to Math TV with Professor V. Here's another integral of the day for you all. We have an indefinite integral of 1 over the square root of x plus x to the 3/2 dx. So let's talk about how to pick an appropriate method to integrate this bad boy. So it may not seem obvious that use substitution is the way to go. I think probably most students would look at this and think trig sub, but you're just going to get stuck because of this x to the 3/2 power. Trig sub works better when you just have x squared underneath the radical or things like that, because then you can use your Pythagorean identities, right? If we end up with like sine to the 3/2, tangent to the, it's just not going to help us. So we're going to need to do a u sub, but right now it's probably not obvious what to let u equal. It won't work if we let u equal the quantity underneath the radical, because I have nothing to be du, right? If you let, this is not a good choice, if you let u equal x plus x to the 3/2, well, du would be 1 plus 3/2 x to the 1/2 dx, and I don't have anything remotely close to that going on. So what that tells me is before we do something like u sub, we need to play around with the integrand, okay? And the only thing really that we can do is factor out the greatest common factor from both terms in the denominator. And in this case, that's an x. So let's go ahead and do it. Let us do the only thing we can do. If I take an x out, now I'm going to be left with 1 plus x to the 1/2 power dx. Okay, and now I can already kind of see where things are going. If you can't just yet, let's break up the radical in the denominator since we have a product, and I can write this as square root of x times the square root of 1 plus x to the 1/2 dx. All right, and then now we're in a position where, yes, I can go ahead and let u equal 1 plus x to the 1/2, and its derivative is sitting here in the integral. Can you see it? I hope so. If not, here we go. So we're going to let u be 1 plus x to the 1/2 power, and then du, the derivative of 1 is 0, derivative of x to the 1/2 is 1/2 x to the negative 1/2 dx. And remember, that's the same as 1/2 times 1 over square root of x dx. Do you see that in our integral somewhere? I do. Here's 1 over square root of x dx. So the only thing I need to do is get rid of this 1/2 over here. So 2 du equals 1 over rad x dx. Hooray! So now we can rewrite our whole integral in terms of u. Let's put the 2 outside. Instead of all of this 1 over rad x dx, I'm going to write 2 du. So the 2's already here. Let's put the du here. And then what's left, we have 1 over square root of u. And now the worst is over. The rest is just the relaxing fun part. Savor it. So let's see, how do we anti-differentiate this? If you need to still rewrite it as u to the negative 1/2 du, no shame in that. Then we add 1 to the exponent, divide by the new exponent. So adding 1 to negative 1/2 gives us positive 1/2. Dividing by 1/2 is the same as multiplying by 2. And then we have plus c. Oh, see how nicely this is shaping up. This is 4 square root of u plus c, which is 4 square root of, what was u? It was 1 plus x to the 1/2, which I could write as 1 plus rad x plus c. Or you could still put everything to the 1/2 power in your answer. Like, I don't care. I don't make my students go back to writing everything with radicals. It doesn't make a difference, but just do whatever your professor wants, right? They give you your grade. They decide how many points you get. So it's just a points game. Play the game, get the points. Make them happy. All right, that concludes the integral of the day. Nothing too long, nothing too crazy, but I thought that one had like a fun little trick to get the u sub going. So hope everyone has a good rest of your day. Give the video a thumbs up, subscribe if you haven't already. Leave me a comment down below. I love reading them. And if you need help with calculus and need more in-depth lectures, just go to the playlist on my YouTube channel. I have everything organized by course, and you can also catch me on Instagram, TikTok, and Patreon if you'd like to support my channel, Math TV with Professor V. Love you guys. Be back soon.